A very warm welcome to the Innovation Hub hosted by Agri-TechE on behalf of the Royal Norfolk Agricultural Association. I'm Laura Bouvet, Knowledge and Innovation Facilitator at Agri-TechE. We're joined by the BBRO, TSL and Crop4Sight today. We'll be discussing how crop variety breeding through genetics and database predictions can help improve resilience to extreme weather events and disease pressures in potatoes and sugar beets. I guess we can now go to Simon. So Simon, tell us a bit more about yourself, your work and the work that you do at the BBRO.
Hello, I'm Simon Bowen. I'm one of the scientists, but I also lead the knowledge exchange program of an organisation called BBRO, which is a British beet research organisation. So we're a levy-funded organisation, a grower levy and also a levy paid by British Sugar, who's the main processor of sugar in the UK. And we look at all aspects of sugar beet research, right from the soil, through seed, through to harvesting and storage. Very much more of an applied nature, very focused on obviously translating new innovations, new ideas into practice.
Paul, I think if you could introduce yourself and talk about the work that you're doing within Crop4Sight and what you'd be bringing to the hub today.
Thanks, Laura. So I'm Paul Coleman, Managing Director of a new startup business, Crop4Sight. Crop4Sight is a digital potato crop management platform. So we're a data-driven business. So we have used data going back over 30 years, which is both variety specific and also season and timing related, to enable growers to use simple insights and forecasts that we create using their crop data to enable them to understand objectively how that crop could and should perform, and then it benchmarks against that.
I mean, 2019 and 2018 as well, with the drought that there was, were pretty couple challenging years in terms of the weather. Can you perhaps give us an example of how the platform that you've developed has helped growers maximize on their crop and in the face of those difficult times?
Okay, so in 2019, the growing season in some areas actually saw a very nice spring, and crop development through to June was quite normal. But what happened in June, there were some very high rainfall events in June in 2019, and that saw a number of crops fall behind on their crop development because the roots were flooded, they weren't picking up the nutrients, they weren't growing at the rate that they were. And so we could see that there was a loss of yield potential there because the canopies hadn't achieved full ground cover as soon as we expected. And with some of those crops, we were able to make a decision and go in and say, okay, we would like to extend the growing season by about a week or 10 days. And so we made the decision to go in, intervene on that crop and go and add some more nitrogen to try and extend the canopy. The other thing that we're able to do off the Crop4Sight platform is also forecast from when the crop emerges. There's a relationship between emergence, the tuber initiation date, and the dormancy break. And when we get on to talking about CIPC, that what we're able to do within the Crop4Sight platform is actually forecast for the grower bespoke to his crop when those potatoes will break dormancy in store when they're lifted. And if we go back to 2018, the data in 2018 was quite interesting in that we'd moved from an AHDB national factual crop in the year before of 6 million tonnes, 6.04 million tonnes it was. And in the drought year of 2018, we ended up with a crop of 4.9 million tonnes. And everybody who we talked to in the industry put that 1.1 million tonne yield loss down to the drought conditions of 2018. But what we were able to show a number of organisations and growers was that because we'd had a cold spring, we'd already lost 500,000 tonnes of yield potential because the crops were later emerging through the ground. So the drought of 2018 actually only affected the yield by 600,000 tonnes, not the 1.1 million tonnes that everybody's associated with that particular year. So when we get a future drought year, we'll go into that with more knowledge about what the overall yield effect is likely to be for the crop. And it won't be as big effect as people believe reflecting on 2018. And we can also show growers the effect of unirrigated crop development versus irrigated crop development. And we're working on building that into understanding what the yield loss is per day. But we've got to continue to build data within the platform to enable us to do that.
Now that's interesting that with some further data mining and exploration, you can really challenge those assumptions. And in this case, I think, show that there was more to it than the weather. And of course, you can use this valuable data to improve accuracy of future predictions. So I think data is a really powerful tool, isn't it? Paul has told us about how the weather has been such a challenging issue for potatoes. But in sugar beet, it's disease pressure in particular that's been on growers' mind, hasn't it, Simon?
Okay, so one of the major challenges facing the sugar beet industry in the UK is how to deal with what we call the virus yellows. This is a virus transmitted by aphids, peach potato aphid, Mysis persicae, which carries a virus and can transmit it into the crop by feeding on the crop. And then obviously it turns the crop yellow, literally. The leaves lose their chlorophyll and go yellow, become very unproductive. And as a consequence, we can see a 30 to 50% loss in yield. So historically, we've been able to use what we call seed treatments, so neonic seed treatments, which protect the plants, particularly in the early stages of the growth when they're most susceptible to it. But the loss of those means we've had to think very differently about how we can manage this problem, and clearly we've had to move to a more targeted regime, which involves a number of elements. First of all, we need to know what the aphids are doing, where they are over winter, how they're going to come into the crop. We forecast them, and there's a number of systems established in the UK. There's a national aphid forecasting network, but more specifically, it's something we've set up a network of stations around the sugar beet area using what we call yellow water pan traps, where we can actually capture aphids and we can get them identified, and we can build up a picture really quickly. We have that now on our website where growers can click on and see what aphid numbers are doing. But also, more importantly, we can now tell whether those aphids are carrying the virus. And we've invested heavily in the very latest BBRO techniques, and we can test the presence of those virus in those aphids really quickly. We can do that as well, and that's now kind of connected through to a whole combined system into a forecasting where to use, and it's a very targeted use of foliar insecticides, whereas before everything got a seed treatment. We're now focusing and targeting pesticides into locations where they're needed. Last year that worked quite effectively. This year has been a bit more of a challenge because we've seen a massive early infestation of aphids into the crop, which pretty much meant everything needed treating at one time. But again, we saw that coming, and of course having that information was critical to work with the growers to make sure they were ready. They were looking at their own crops. It's been a very important part of the knowledge exchange program, is to say, whilst we can look at our yellow water pan traps, but they are really an early warning system, you need to go and look in your own crops as well, because the way aphids move around fields and crops, there could be one field, but over a hedge you might not find any as well. And we're very keen to make sure that our use of foliar insecticides is incredibly targeted.
Thank you, Simon. I think you've clearly shown us that virus-carrying aphids have a significant impact on sugar beet yields. Now, disease pressure is also a huge problem for the potato industry. TSL, can you talk us through how you're using genetics to develop potatoes with a strong armoury of defences against diseases?
Hi, I'm Sebastian Fairhead. I'm a postdoctoral scientist in Jonathan Jones's group. Disease resistance is more durable if you have different genes recognising the same pathogen. So my job here is to identify new sources of resistance against late blight from wild relatives of potato that we can move into commercial cultivated varieties. I also have a background in arable farming, so I have a real interest in both the fundamental science of plant-microbe interaction and the translation of that science into a commercial context.
Jonathan, tell us about the work that goes on in your lab.
So we at the Sainsbury Lab work on how plants resist disease and how microbes get around plant defences. We're also interested in seeing some of that knowledge used to create solutions for important crop disease problems. My lab, we got a basic science program, but we've also got a more applied program, which is focused on resistance to potato late blight, the biotic cause of the Irish potato famine, and still a very important disease that requires farmers to spray typically 10 to 15 times a year. So our ambition is to try and replace chemistry with genetics to control disease. And we've combined this disease resistance to blight with genes from the Simplot company in the US, which improve the tuber quality so that the tubers, when you store them at cold temperatures, accumulate a lot less reducing sugars. And reducing sugars, when you cook at high temperature in a deep fat fryer, you get blackening, and you could even make some nastier compounds. And so if you prevent the accumulation of these reducing sugars, then you get better quality crisps and chips. And also we've got a trait that reduces the propensity to bruising damage as well.
My name is Agnieszka Witek, so I've done both. I've participated in the identification of some of those resistant genes. And at the moment, my project is to deploy this, to basically try this combination of the genes in the field, in the commercial varieties, Maris Piper and now also Hermes, to evaluate how that combined stacked resistance performs in the field. And so far, we've got stable, repeated year-over-year resistance to late blight. So we are pretty happy to be in possession of about 10 lines that have, in the foreseeable future, commercial potential.
Thanks, Agnieszka. Simon briefly touched on the loss of an important chemical to the sugar beet industry, but the potato industry is going through something similar with the loss of CIPC. Now, why is this such a big issue, and how are you addressing this at TSL?
Okay, well, we use this term CIPC. So it's chlorprotham, which is a chemical applied to tubers to stop them sprouting. But it is something you don't want to have in your diet. And so EU regulations, I think quite rightly, have made it much more difficult to use this particular sprout suppressant. But if you lose the sprout suppressant, then you've got a problem. If you want to store potatoes at cold temperatures, then you get this cold-induced sweetening. And if you store them warmer to avoid that happening, then you need a sprout suppressant, otherwise they all sprout on you. What we want to test is whether or not we can avoid the need for using CIPC by you putting in this gene, which means that it suppresses the production of the invertase, which is the enzyme that converts sucrose to glucose plus fructose, which are the reducing sugars that you don't want for high temperature cooking. So we'll be able to avoid the need for CIPC by storing at lower temperatures where you get less sprouting if you use this gene that prevents that conversion. So that's we hope that'll help the industry cope with the abolition of availability, loss of availability of CIPC. I add something about the gene editing and GM because we've sort of I think it's important to distinguish the methods. So with gene editing, at least the simple form that there's talk of an amendment about in the Lords at the moment. This is about enabling one to identify a gene which has properties that you want to change or remove, and you can just go in and tweak that gene so that it either doesn't work or it's got a slightly different function. So you're doing something to the genes of the plant or a gene in the plant, but you're not putting anything new in. You just got to reaching in with some tweezers and just tweaking it a bit. Now that's fine for some things. You could do some useful things with that, but for what we do, as Agnieszka said, we're moving genes from wild relatives of potato that confer resistance to late blight, and you cannot do that with gene editing. That's not gene editing. And I would add that for the invertase enzyme, or the enzyme that gives you brews, which is called PPO, you can make a knockout of those using editing, but at least for the invertase, there are actually consequences for that in the rest of the plant. So the nice thing about what we're doing with the Simplar technology is we have tuber-specific changes to the invertase that you cannot achieve except by using the GM method.
Just as a sort of broader and stand back perspective, that's one example where you've got a regulatory framework that's resulted in the withdrawal of an active that works somewhere along the supply chain. And there is a solution or an answer that can be found to it from genetics. And if you look at the withdrawal of all of these things, be it neonicotinoids, be it CPIC, there are genetic solutions that effectively can feed into those pipelines.
That is such a good point, Sebastian. Simon, what's your views on this?
So I think just to pick up on this theme of obviously, improving varietal resistance to specific problems, I think there's a massive research effort going in BBRO into this, using conventional breeding techniques, I should say, and we're very much in favour of advancing the discussion and debate around the use of CRISPR. But I think one of the things we would be really keen to demonstrate to growers, we cannot rely on a genetic solution which is going to deliver everything. And we would very much be talking to growers about the need to make sure we keep our integrated control approaches going. So yeah, we would show our growers the difference between some of the varieties we're already detecting in terms of their resistance to virus, the yellows. But we'd also be talking to them about the importance of making sure they do everything they can on their farms to improve beneficials, the ladybirds and the lacewings, which are natural predators of aphids. There's a lot we should do there. We'd also be talking to them about the need to make sure they have farm hygiene. And I think we might be sharing with them some horror stories we've seen on farm, from recognising it was a difficult harvest season where sugar beet is left behind and it's sprouting and it's a source of aphids, it's a sort of virus into crops. We have to get that right. And again, the other one I think we will be working really hard with growers in, because it is complicated, is to be able to identify aphids in their plants. They are small. And the thresholds work on wingless aphids, which are even smaller, and we are developing new techniques to help growers, but at the moment it involves people going down on their hands and knees and looking and counting. So a lot of effort to help them make sure they can identify Mysis persicae, which is the one we have to really focus on, and they're not confusing it with other insects. We haven't had to go down on our hands on these in our crops for many, many years, and we're all a bit ring rusty, and growers find it very challenging. But it's really important we get that right, so we can actually target a limited number of foliar insecticides at the right time when we really need them.
Okay, and in terms of aphid monitoring, are there any technologies out there that be able to, perhaps more in terms of the symptoms within the crop, that would be useful to aid manual surveying?
Well, with all respect, by the time we see the symptoms in the crop, we're far too late. Really, it's all about keeping ahead of the transmission of the virus. So we're very keen to think and understand how we can improve our aphid monitoring systems. And we are looking at some technologies which involve obviously looking at visual images to see if they are sensitive enough to look at the aphids and do that for us.
Thank you, Simon. That's interesting, isn't it? You've mentioned the importance of preventative measures such as monitoring and gathering evidence. That's something I'd like to explore a bit more. Paul, could you build on this with the work that you're doing at Crop4Sight?
So if you look at some simple stats of a crop produced in a field, typically for fresh potatoes, for example, that are washed and packed, only 72% of those potatoes make it into the finished premium pack. The bit that we have targeted is that 10% of that waste is because the crop produces tubers that are outside of the commercial sizes required. And so what Crop4Sight does, it works right from the starting point with a dynamic seed rate module, which enables growers to tailor their seed rate to the yield they're trying to achieve, the crop size, their planting date, and takes account of the chronological age of the seed. So he can set a very precise target, and that enables him to put in the correct amount of seed at the start. So there's potential savings there. And then as the crop then develops, we're able to forecast for that grower what the yield potential should be of that crop. So we can then look at, as the crop growth is progressing, where that grower is losing yield within that field, and then also to look at the size distribution and forecast that through to the end of the growing season, to give him a more precise timing around when to kill the crop off to achieve the absolute optimum value per hectare. So on a relatively small potato enterprise of about 60 hectares, the last 3 years data has shown that there's typically up to £22,000 more value opportunity by having some relatively simple objective data available as insights and forecasts to enable the grower to make the choice about whether they can and want to take that opportunity. And that's quite important. And then when you get into weather events, you know, changing what you do to maybe bring your crops earlier to avoid the very wet back end of the season like we had in 2019, rather than making guesses about what do I change, we can show the growers very simply using the platform what the input changes will mean in terms of timing and yield and size distribution.
Thank you, Paul. I think it just goes to show that data gathering and predictions can make a big difference, a positive difference to a grower's business. Okay, well, I guess just to wrap up, I think it's been quite interesting to hear from everybody's perspectives. I think it just goes to show that solutions have to be multifaceted. We can come at it from different angles, and making sure that's all grounded within the challenges that we're faced with. And 2019 has certainly been a challenge. So I guess perhaps if we could finish with some key take-home messages that you would like people coming to the virtual hub to take away with them, I think that would make a nice wrap-up. So Simon?
So what I would say, particularly again in the context of controlling virus yellows, which will be #1 priority for all sugar beet growers, is keep in contact with the BBRO information, keep looking, keep inspecting your crops, understand the nature of the problem, understand how to identify the right species of aphids, use the information we're putting out there, it's all on the BBRO website, and use that to target sprays at the right time. And more importantly, make sure you can get your crop to around the 12th leaf stage as quickly as possible, because after that time we acquire some mature plant resistance, and then the crop is much less likely to take virus on board.
And Paul, what would be your key message to people coming into the hub, whether they're growers or people just interested in new technologies?
The takeaway message would be that it doesn't matter how professional you are in your potato production, the use of data can show you where there are further opportunities to improve your efficiency, reduce waste, improve your carbon footprint, but fundamentally improve the financial return for the investment, the heavy investment that potato growers put in.
At the Sainsbury Lab, what would be your key take-home messages?
We need to maintain an integrated approach to controlling pest, weeds and diseases in potatoes, sugar beet and all crops for that matter. We're losing fungicides at an alarming rate, which is putting a selective pressure on the remaining fungicides to effectively lose efficacy. We can integrate genetics in a safe manner into the way that we produce food, which will give us more tools in the toolbox, and it will provide safe food for consumers.
Yeah, I would agree with that. We need to be a step ahead to provide that we can survive in the challenging world, which is getting more and more challenging. And it would be a shame to lose such a valuable tool, which is genetics. Of course, it has to go hand in hand with all the other solutions. We cannot promise that we won't ever be using any chemical controls. Of course, that has to go hand in hand. It has to be evaluated as we go. But anything that can aid us in fulfilling the demand for food, for animal feed, and for other products that come from potatoes or sugar beet, any tool like that is valuable tool, and let's use all our tools that are, like, genetics is nature-based. Let's remember that it's nature-based.
Let's use all our tools. Well, I think that really nicely sums up our discussion. We can use data gathered in the field to predict future scenarios and take important decisions earlier. We can use genetics to develop crops adapted to pressures from the environment and supply chain specifications. So I think if I was to sum this up in a sentence, it's all about predictions and prevention for increased crop resilience. Thank you very much for joining us. We hope you enjoyed this discussion. Make sure to visit BBRO's, Crop4Sight's and TSL's exhibitor pages at the Innovation Hub. And if you've got any specific questions for Simon, Paul and the team at TSL, there is an opportunity to do that on their exhibitor pages. So make sure to send your questions through to them. Now, there's plenty more in the Hub, so enjoy finding out about other innovations that we have on show and have a go at spinning the wheel as well. Thank you very much for joining.